In this video, we'll be talking about battery monitoring and cutting off batteries before they get too low, for example. Now, there's lots of reasons why it can be very useful why we do battery monitoring. For example, our user, when they look at their mobile phone, it's very helpful for them to see how much charge they've got remaining so they can know they'll put it on charge, or they know they can go out and they can reasonably expect it to work for a given period of time. It can also be useful if we've got, for example, a bunch of remote nodes out in the wilderness or something like that, and we know some of them are getting low, their battery's getting low. We can schedule in a service call to replace the batteries or charge up the batteries or something like that. We know something's gone wrong. There's also some batteries, particularly lithium batteries like lithium ion, lithium polymer, that shouldn't be discharged too low. And here's a brief video here that shows what can happen if we don't charge batteries correctly and if we discharge them too low. One of the things, and these are lithium polymer batteries, it's a big problem with them in particular. If you discharge them too much and then try and charge them up, they start ballooning out, getting larger and larger and larger, and they can catch on fire as well. So we'll see an example of this. So that's what you don't want to happen in your mobile phone or your laptop, particularly while it's in your hands. Well, what can we do then? Well, if batteries are monitored, we've got a lot of scope there. We can, for example, put the device into a low power mode to prevent them from discharging too low if they're getting low. We can alert the user and say batteries are low, batteries require a replacement or charge, and we put the device into sleep mode so it doesn't discharge them so low and damage it. And we can then come out of that sleep mode when our battery voltage is increased again to a safe level that we can turn things on and start drawing power again. There's a few different options available to us there. Well, how do we measure our battery voltage, or how low those batteries are? Well, we use the analog digital converter, of course. We've used it in previous lectures, measuring a potentiometer, for example, and measuring what voltage is occurring on the sensor. Well, here what we want to do is use a voltage divider. So we divide down our input voltage using a voltage divider, and we get it in the range that is safe for the microcontroller to accept into one of its analog pins. And that will mean that that voltage will change over time, but it's still linear. One other thing to consider though, if we're using a regulator, we want to put that voltage in before we regulate it. There's not much point regulating the voltage and then doing a voltage divider on that, because it will always be at 3.3 volts or 5 volts or whatever it is. We want it before that regulator so we actually get what the batteries are saying. If we're not using a regulator, we also need to consider what our reference voltage is going to be, because we don't want to use our external voltage or our battery voltage as a reference voltage, because what's going to be happening is they're going to be both decreasing over time as it discharges and increasing over time as it's charging up again. And most of our microcontrollers have an internal reference voltage generator in there. And so we use that internal reference voltage generator to compare our scaled down battery voltage against. So here's basically what our circuit looks like, our VBAT, our little voltage divider there, and into our microcontroller circuit. And once again, we use that internal voltage reference there that we use to compare it against. So our internal voltage reference might be significantly lower than what our microcontroller is supplied with. For example, in some microcontrollers, it might be 600 millivolts, which is significantly lower than the 3.3 or 3.6 or 5 volts that's required to supply it. So we need to make sure that when we scale our voltage down with those voltage dividers, that we get it low enough that it's below that internal reference voltage for the highest charge that we expect the battery will have.